Hi guys, welcome to Calibrations and Fashion YouTube sewing channel, and today we want to learn the reading and understanding of our flexible tape measure. This is one of the fundamentals, the basic that one needs to know and understand as a sewist. If overlooked, then it might contribute to some fitting issues because one would tend to be rounding off and rounding up measurements because of the failure of the understanding. Here I have three samples of the flexible tape measure. What is even a tape measure in the first place? A tape measure is that instrument that we use to measure the distance between one point and another point. These samples are the flexible ones which we as sewists we make use of because this helps us to be able to wrap around our body parts and be able to take measurement from one point to the other. We have some that are not flexible, and because it will not be able to go around our body, we don't use those ones. So we make use of these flexible ones which can easily go around the part of the body. And these are the types that you have readily available in the market. In terms of the size, we have the quarter, we have this is half, and this is the 1 inch. We have some that are much more wider than this, but whichever one you find comfortable to use, every flexible tape measure has two sides. We have the centimeter side and we have the inches side. Some people are comfortable with the cm, while some people are comfortable with the inches. It's just that for the cm side, the calibration are so done tightly so that it eliminates the issue of rounding off or rounding up. But when you're working with the centimeter side, you'll be having larger figures, values to deal with. Take for instance, you are working with skirt length 20, for instance. Length 20 now becomes 51 centimeter, and you'll be wondering, my skirt length is 51, so you'll be working with higher figures. So in order not to deal with the issue of higher values, you can do your your inches. But with the inches, you have lesser figures to deal with. But for today's class, I'll be focusing on the inches side because that's the side that most times we use. So I've gone ahead to replicate what you have ideally on a flexible tape measure. Many a times the one that we have available in the market are calibrated in 1/8, and that's why I have this other sample here. If you look at this, this is calibrated in 1/16. You can see that in between 2 and 3, for instance, you have tiny, those are lines of calibration, and if you count what you have here, you have 16 of that, whereas for this and this other sample, we count what you have in between a particular inch and another inch. You just have 8 lines of calibration. So these two are calibrated in 1/8, whereas this is calibrated in 1/16. Ideally, this is what we should have on every tape measure. So I'll be using this now to be doing the analysis so that we can get it right. Now I've gone ahead to replicate what we should have on an ideal tape measure. So from distance 0 to 1 now, we should have 16 lines, the tiny lines of calibration, so that the first one becomes 1 out of the 16, which is 1/16. The second line becomes 2 out of 16, that is 2/16. The third becomes 3 out of 16, which is 3/16, and so on like that. And when you get it, this is 15/16, and the last one will be 16/16. And since it's 16/16, we can actually go ahead to divide, and by the time we divide, it gives us 1, and that is why you'll be having 1 inch here. So from this 0 now to this 1, we have 16, and 16/16 will give us 1. Now what will now happen is we'll be having some that are odd numbers, we'll be having some that are even number. Like for instance, this second line now we have 2/16. We can go ahead to actually still further break this figure down. 2/16 dividing it, we have 1 and 8, so that becomes 1/8. So what happens is those that even numbers that we can further break down, we'll break them down and they will now graduate to another figure which is a higher value. So what we have is to 16 now. By the time you break it further, you have 1/8. So this will be further broken down to be giving us 1/8. So this gives us 1/8. So this other line now is where we are going to be having the 8s. The first line here we are having the 16s. This second line we are going to be having the 8s. So we are going to be dividing each one that is divisible by 2. So 3/16 cannot be divided, but 4/16 we'll go ahead to divide it by 2. So the upper part now becomes 2 while the lower part becomes 8. So here we are going to be having 2/8, which means the numerator will be 2 while the denominator will be 8. So this graduates into a higher figure now, 2/8. The next figure is 5/16. We cannot break it down, so we leave that. So the next one is 6/16, and by the time we are dividing it by 2 as well, this graduates. So the numerator, the upper part now becomes 3 while the denominator becomes 8. So we're having 3/8. The next one is 7/16. We cannot divide, so here we are having 8/16, and by the time we divide by 2 as well, we'll be having 4/8, which shows that the upper part, the numerator now, will be increasing by 1 1 1 1 while the denominator remains as 8. So the next one is 9/16. We can't break it down. The next one here is 10/16, and that will give us 5/8. So that means this will remain. The 12/16 now becomes 6/8. 13/16 remains. 14/16 then becomes 7/8. 15/16 remains. Then this one now, by the time we divide it, we'll still be having 8/8. To be having 8/8 here. So this line now will be giving us the 8s like this. So just the same way we have done this, breaking them further, we can go ahead now and still break all of these ones further. 1/8 remains that we can't go ahead to divide, but 2/8 can still be further divided, and by the time we divide, this one graduates now. Dividing it by 2, the numerator, the upper value, becomes 1 while the denominator becomes 4, and that gives us 1/4, which is our 1/4 inch. So if I go ahead to divide this now, this graduates to a higher figure now, and be having 1/4. 1/4. Now 3/8 remains. We cannot further divide, while 4/8 we can divide, and that gives us 2/8. So this graduates upwards again, and we're having 2/4. Then this 5/8 remains, while this 6/8 will graduate upwards again, and that will be giving us 3/4. And this now 8/8 now, we further divide it, we just be having 4 and 4. So many a times this is the value we'll be having 1/4, and we're having 2/4 here, 3/4. So this is 1/4. Let me rewrite it very well. So on this line now, we'll be having the quarters: 1/4, 2/4, 3/4, and 4/4. So these 2/4 now, you can further break it down now, and breaking it down, you'll be having half an inch. By the time we divide it by 2, the numerator becomes 1 while the denominator is 2. So we'll be having half, and 3/4 remains. We cannot break it down. Now 4/4 can be divided again, and what do we have? We still have our 1 inch. So if this is 0.0, you'll be having half here, and you'll be having 1 inch, which means from this 0.0 to this half an inch, all of this was what actually gave rise to this. All of these measurements fell in place. That's why we are having half. And between this half and 1 inch, all of these actually will fall in place. So now with this understanding, when you have your tape measure and you are measuring a particular distance and you have probably measured, let's assume you have measured 10 now, the value you need is 10. Let's assume the value you need is 10 and this particular line. Instead of you just rounding it up to say it's 11 or say it's 10.5, what you do is, this is 10, which is the whole number here. You count what you have in between this 10 to the value that you need. So if you count now, 1, 2, 3, 4, 5, 6. This is 6 out of 8 now. So you have 10, 6, 8. And because you can still break this down, divided by 2, this is 3. Divided by 2, this is 4. So the real value is actually 10 3/4, which is 10.75. So that's how to read it. And again, let's do another example. Let's assume you are working and the value you need is probably this value here, and this is 22. So what you do is, 22 is the whole number. You note that 22, then you count 1, 2, 3. This is 22, then 3 out of 8, because from this whole number 22 to this 23 is actually 8 lines of calibration, which is 1, 2, 3, 4, 5, 6, 7, 8. And since this is the value that you need, and you need to read very well, so you count 1, 2, 3. So that is 22, 3, 8. 3 out of 8. 22, 3, 8. So that's the figure that you need, and you just note it like that without having to round up or round off. Again, let's do another sample. Let's assume I'm working and what I need is 31 and this other value here, this particular value here. I don't just need to round it up and say it's 32. No, I'll note it, this is 31, then count the lines of calibration: 1, 2, 3, 4, 5, 6, 7. So that is 31, 7, 8, 7 over 8, and that is what I'll be working with. So this is how to actually read and understand your flexible tape measure, so that you don't need to be rounding up or rounding off as the case might be. So what we are trying to say in essence is, from a particular point to another point is usually 16, but this type of flexible tape measure that we have readily available in the market is calibrated in 8, which is still good to go to working with. Or you just need it from this point to this, from this whole number. The first line will be 1 over 8, the second line will be 2 over 8, and because this is 2 over 8, you can break it down. That's why we refer to as 1/4, because 2 over 8 you can still further break it down and say is 1/4. So this is 1/4. So the next one is 3 over 8, and that remains. This fourth line now, it is 4 over 8, and because we can break it down, 4 over 8 now becomes half, and that's why we often say this is 6.5. The next one is 5/8, and we cannot break it down, it remains. The next one will now be 6/8, and because it is 6/8 now, we can break it down, and we'll be having 3 here, divided by 2, 3, divided by 2, 4, and we say it is 3/4. So this will be 6 3/4, while this seventh one now will be 7/8, and because we cannot break it down, it remains like that. So this is 6 1/4, 6/1/8, 6 1/4, 6 3/8, 6 1/2, 6 5/8, 6 3/4, 6 7/8, and of course this will now give us a whole number, which is 7 inches. So that is how to read and understand our flexible tape measure. I hope with this explanation you now have a better understanding, and you wouldn't have to be rounding up or rounding off your values, so that it helps us to eliminate fitting problems. When you round up your measurements, sometimes you might go and add up or reduce the actual value, which might not make the garment to actually fits well on the body. If this video has been helpful, kindly give it a thumbs up. Don't forget to subscribe to our YouTube channel and also turn on the notification bell so that you get notified every time videos are being uploaded on this channel. On this channel, videos are uploaded weekly and not just anyhow video. They are top-notch where you learn the fundamentals and how to do things professionally. Until my next video, thank you for watching. Bye for now.
La Perry College of Fashion, raising professionals.